Hi and welcome back to another Mr. Talbot Maths video. In this week's video we're going to be looking at this question here, which is a question from a math challenge in 2019, the intermediate one to be specific. Okay, let's get into the problem. So there are three touching semicircles with radius 1 which lie inside an equilateral triangle, which each semicircle also touches. The diameter of each semicircle lies along a side of the triangle. What is the length of each side of the equilateral triangle? Now the first thing we want to do is try and put as much information on to the diagram as possible. So first thing I've noticed is that this is an equilateral triangle. So this angle down here is 60 degrees, and well, all of the corners will have angles that are 60 degrees. And then obviously we've got our semicircles and we've got the radii of them, or the radius of each one. And so we need to think about a way in which we can use that, and you might want to put that onto the diagram, but I'm cautious that actually I don't want to have it all over the place. I need to think about actually where this is going to be most useful, because just putting it on the outside isn't really going to help, because you've got these little gaps in between the semicircles on the edge of the triangle. So one thing I know about circles in general is that if I have a tangent to my circle, so that's a line that just touches the outside of the circle and doesn't go through it, then my radius will meet my tangent at 90 degrees, and that's one of the circle theorems. So what I'm going to do is I'm going to draw a straight line, a radius, from the centre of this circle to the edge here. Okay, so there's one of my radiuses, radii to be specific. Now I'm going to draw another one from here, and it's going to go through where these circles touch to the centre here. Once I've done that, I am going to put on the lengths. Now I want to draw one more because at the minute this has given me some triangles which go along here, but what I can't definitely be sure about is that these radii here, or from this right-hand semicircle going to the centre of the left-hand semicircle, I can't be sure that it's going to start at 90 degrees over here, because they don't sort of tangent, it just meets the other semicircle. There's no straight line there. So what I also want to do, I want to draw a straight line from the centre of the right-hand semicircle to where that touches the side of the triangle. Now once I've done that, I can put on my right angles in here. And I said at the start that angle there was 60. I've got a right angle here as well. Okay, now that will tell me some other angles. I could work out that this is 30. I can't really work out any angles here, but what I do have is the lengths here. So I can put these lengths on because I've got the radius, or radii, depending on what we're referring to. Okay, now what I want to do, I actually want to work out the length of one side here. Now I'm focusing purely on the bottom of this triangle, and you could do exactly the same process with the other sides of the triangle, but obviously it's symmetrical. So I've got an angle here, I've got a right angle triangle, and I've got a side for this left-hand bottom triangle. So to work out this length here at the bottom, I'm going to use trigonometry. So this one is opposite this angle, and then opposite my right angle is the hypotenuse. So with trigonometry, SOHCAHTOA, I'm going to be using sine here to work out this side. And actually sine 60, sine of my angle, is equal to the opposite, which is 1 over the hypotenuse. Now, if we multiply by h and divide by sine 60, then what I get is that h, or the hypotenuse, is 1 over sine 60. Now sine 60 is root 3 over 2. So timesing here, numerator and denominator by 2, I end up with 2 over root 3. And so this length here, from the bottom left of the triangle to the centre of that bottom semicircle, is going to be 2 over root 3. Okay, and that's the first bit. Now the next part of this bottom side, I am going to be using Pythagoras, because I've got a right angle triangle and I've got a hypotenuse with a length of 2 and then a vertical height of 1 or a shorter side of 1. So this side here is going to be the square root of 2 squared subtract 1 squared, and that's going to give me an answer of root 3. Now, this bottom right here, I'm going to need to work that out. I'm running out of the room down underneath the diagram, so I'm just going to do it over to the left over here. But I've got, again, an opposite side, opposite the angle of 60 degrees of 1, and I want to work out this bottom side of that triangle, so I want to work out the adjacent, because hypotenuse is opposite my right angle. So, opposite and adjacent, that's going to be tan. So tan 60 is equal to opposite, which is 1, over my adjacent, which is what I'm trying to work out. So now if I multiply by the adjacent, divide by tan 60, I get 1 over, now tan 60 is root 3, so I get 1 over root 3. So that's what this bit is here, 1 over root 3. And so now I've got all of the different parts of the side of the triangle. I just need to add those together. So what I'm going to do is I'm going to do 2 over root 3, and then I've got root 3 here in the middle, so plus root 3, and then plus 1 over root 3. Now, of course, you could plug that all into your calculator and it would tell you what it is straight away, but it's always quite nice to just do it a bit algebraically. So 2 over root 3 plus 1 over root 3, that is 3 over root 3, plus root 3, because we've still got this root 3 in the middle here. Now, if I do 3 divided by root 3, well, think about what I'd have to times root 3 by to get 3, it would be root 3. Another way you can do that is multiplying top and bottom of 3 over root 3 by root 3, and then you get 3 root 3. Root 3 times root 3 is 3, so we get 3 root 3 over 3 root 3 over 3. It's a bit of a tongue twister. Cancel those 3's out top and bottom, or divide by 3 top and bottom, and we end up with root 3 plus root 3, so we get a final answer of 2 root 3. And that is the length of each side of this triangle. Okay, thank you for watching. I hope you enjoyed that. Thank you for taking the time to watch my videos. I really appreciate it, and I really appreciate all the likes and everybody that subscribes to the channel. If you like this video, then there should be plenty more videos just up here. Hopefully it's here. That's where it should be, the one that you want to watch next. Okay, see you in the next one. Bye-bye.